wired personal area network. Then second type of the network is a LAN. As we covered, we have four types of the networks. PAN, personal area network, that is completed. Second type is LAN. The full form for the word LAN is local area network. Local area network is group of computers. You can observe in this image, group of the computers connected together in a small area. For example, in your lab, in your college, or in a building, or in your office. So if you want to connect your computer system one with another in a small area, we use local area network, simply called LAN. LAN is used for connecting two or more personal computers, at least two, minimum is two, through a communication media. We can use some communication media that might be any type of the wires like twisted pair cables, coaxial cables, and so on. So this is the connection. If you observe this image, these computer systems are connected with some communication media. Okay, that is, we have different type of the cables. We will cover that later on. What are the different type of the cables we have? We have a separate topic called transmission media. In that will be covered in detail. But as of now, just now, we may use any different type of the cables to implement a LAN like a twisted pair cables and coaxial cables. And the LAN is very less cost as it is built with inexpensive hardware such as hubs, network adapters, and Ethernet cables. So if you want to create any LAN in your labs or in office, we use a limited number of the hardwares. Those are very inexpensive. So the hardware requirements we use for the LAN are hubs, Ethernet cables, and network adapters. And the data is transferred at extremely faster rate in local area network. Okay. So when the computer systems are connected with LAN, the data can be transferred with very fast. Suppose if you want to transfer any file from your computer, from one computer to another computer with wireless mechanism and with wired mechanism. In this case, the wired mechanism uses LAN, let us assume, that takes less time to transfer the data. Then third category is MAN. MAN stands for Metropolitan Area Network. So this is just larger than LAN. If you observe, PAN is a very small network. LAN is a larger network than PAN, where MAN is a larger network than LAN. Okay. Then a metropolitan area network is a network that covers a large geographic area by interconnecting a different LAN to form a large networks. In simple terms, we can say that this is a network of LANs. For example, X person have two buildings. Let us assume that a person is there, that person name is X. Let us say that person has two buildings. In one building, they have LAN. In second building also, they have the LAN. But sometimes that person wants to transfer the data from building one to building two. In such cases, we use MAN. This is one case. Okay. Suppose we have two cities or suburban cities. To connect such type of the cities also, we use MAN. A best example is city cable channels. Okay. You may find local channels, local TV channels, city cable channels. They used internally MAN, Metropolitan Area Network. Government agencies use MAN to connect to the citizens and private industries. And this MAN is higher range than LAN, local area network, as we covered. So this is a example figure to understand the MAN. Observe here. This is one LAN. Okay. And this is another LAN. Like that, in this image, we have taken four LANs. Let us assume that this LAN is one building, this LAN is in another building, and a third LAN in third building, fourth line in fourth building. But if you want to communicate from one building to another building, you can use MAN, Metropolitan Area Network. So the connection of these four lines creates one network. That network is called MAN, Metropolitan Area Network. So generally where we use MAN? MAN is used in a communication between the banks in a city. For example, we have a large city, and in that, let us assume that there are four branches of SBI Bank. And the banks also can communicate, right? Because we can get the details of one customer from another branch also. Okay. Like that, to connect the same banks within the city, they use MAN, Metropolitan Area Network. And it can be used in airline reservation system also, college within the city. It can also be used for the communication in the military also. So these are some use cases where we use MAN. And fourth category and very largest network is WAN. WAN stands for Wide Area Network. So a wide area network is a network that extends over a large geographical area, such as it is used to connect the states or countries. If you want to connect one country with another country, you can use WAN, that is Wide Area Network. So the wide area network is a quite bigger network than the MAN, as I covered already. Very small network is PAN. Next level is LAN. Next level MAN, and next highest level is WAN. The WAN network is not limited to any single location. It spans over a large geographical area through a telephone line or fiber optic cables or satellite links. So the wide area network is used to connect countries to countries, one country to another country. And here we are using the transmission media. So telephone line or fiber optic cables or satellite links are used as a communication media. Very best example for the WAN is internet. So internet is one of the biggest WAN in the world, as we know. See this image, you can understand what is WAN. So where we can connect different type of the MANs or LANs, obviously sometimes directly. See this LANs, four LANs. If we combine four LAN networks, it create one MAN. Okay, and here also another four LANs created one MAN. So this MAN is connecting to WAN. This MAN is also connecting to WAN. Nothing but collection of these many networks creates another network. That network is called WAN, Wide Area Network. The next topic is how many times we can connect the devices in the network. What are the different type of the connections we have in the context of networking? A network is two or more devices connected through a links. We know that a network is a connection group of the computers connected together in simple terms. And a link is a communication pathway that transfer the data from one device to another device. We must use one link between the devices. If you want to transfer the data, compulsory, we need to use some transmission media. For example, it is simple to imagine any link as a line drawn between 2 points. For communication to occur, two devices must be connected in the some way to the same link at the same time. Okay, nothing but if you want to send the data from X system to Y system, those two systems must be connected in some way. So how many ways we have, we'll cover later on. So we have two possible types of the connections. Those are point-to-point connection, or you can say point-to-point configuration, and multi-point configuration or multi-point connection. See the first one, point-to-point connection, or you can say point-to-point configuration. With help of this image, you can understand the concept easily. For example, we have one device and we have second two devices, one and other. And let me give a simple example. We have CPU and a monitor. We know that already we use one cable to create the link between CPU and monitor. So this link is called point-to-point connection. In simple words, in point-to-point connection, the devices maintain a dedicated link between the devices. A dedicated link, a dedicated transmission media, or a dedicated cable is connected between CPU to monitor. So this connection is called point-to-point connection. And in this case, the entire capacity of the link, every link is nothing but a cable. Every cable has some capacity. The entire capacity of that link is reserved for the transmission between those two devices, because only we are using two devices. So the total capacity of this link is used by those two devices only. Next one is multi-point connection, or you can say multi-point configuration. By seeing this image, you can understand the topic. See this? There is no dedicated link maintained between the devices. Rather than there is one link between one device to another device. Let me take a different color. Right. So here we have one link from server to client 3, let us assume. And for this link, several systems are connected. This type of the connection is called multi-point connection. In simple words, we have one cable and multiple devices are connected in multiple places. This is what multi-point connection. And this is also called multi-drop connection also. And here the important point is, so the capacity of the link is, the capacity of this link is shared among the n number of the devices, where n indicates how many number of the devices connected to this particular link. For example, here four, four more systems connected to this link. So here the capacity of this link is shared among all the devices connected to that link. But in the previous case, in the point-to-point connection, the complete capacity is shared by two devices only. So that's why point-to-point connection has a greater speed than the multi-point connection. That is the important point you must observe here. Next topic is topology. Very simple topic and very important topic in networking concept. Then what is topology first? Very simple. Topology is nothing but the way of arrangement of the cables in simple word. Okay, the way of the arrangement of the cables in simple terms. And if you want to give somewhat next level of the definition for the word topology, topologies may define both physical and logical aspect of the networks. Okay, this is about the definition about topology. And we have the different types of the topologies. Very famous topologies are bus topology, ring topology, tree topology, star topology, mesh, and hybrid topologies. These are the different types of the topologies depending on the way how we are arranging the cables, how the devices are arranged. Depending on that, we have six types of the topologies. Let us discuss these six topologies one by one. First one is bus topology. See this image, you can understand it. In the bus topology, we used only one cable. We used only one cable here. This cable is called backbone cable. See, the bus topology is designed in such a way that all these stations are connected through a single cable. That cable is known as backbone cable. Here, these are treated as stations here. All these stations are connected to a single cable that is called backbone cable. Then each node is connected to the backbone cable by drop cable. Node is nothing but what are the devices connected to this backbone are called nodes. In simple terms, whatever the device connected to a network, the device is called node in general. The general terminology is node. And every node is connected with a drop cable. So in this figure, you can understand. So this is a drop cable. And this is also a drop cable. With help of this drop cable, these systems are connected to the backbone cable. And here we have the two ends for the backbone cable. These are called terminators, ending points. Next, here the data flow direction is bidirectional. You can observe here. The data can be transmitted from left to right and right to left. The data flow direction is bidirectional. When a node wants to send a message over the network, it puts that message over the network. Then all the stations available in the network will receive the message whether it has been addressed or not. The meaning of that statement is whenever any person, nothing but any device or any person wants to send any data through this main cable or backbone cable, that will be delivered to the all the station, even though the data is addressed to the station or not, that will be delivered to the all the stations connected to that backbone cable. The bus topology is mainly used in Ethernet 802.3. In a network standards, we have some numbers for the all technologies. So the number for the Ethernet is IEEE 802.3 and 802.4 standard network. The bus topology is mainly used in Ethernet, that is 802.3 and 802.4 standard networks. The configuration of bus topology is quite simpler as compared to the other topologies. We will see other topology structure later on, but this is very simple network it has when compared to the other topologies what we are going to discuss. And the most common access method of this bus topologies is CSMA. This is very important point. How the data can be accessed if the data is available in the main cable or backbone cable. For that, in bus topology, the access method used to access the data is CSMA. CSMA stands for Carrier Sense Multiple Access. Carrier Sense Multiple Access. Now, let me tell you some more important points about the CSMA. It is a media access control. So as I covered, to access the data available on the backbone cable, we use CSMA. That is used to control the data flow so that the data integrity is maintained. The packets do not get lost. Okay, an integrity is maintained with help of the CSMA. And there are two alternative ways of handling the problems that occurs when two nodes send the messages simultaneously. Nothing but if we observe this image, for example, if this node is trying to sending the data, and at the same time, this node is also trying to sending the data, there is a chance to collision. There is a chance to collision, right? So there are two alternatives to avoid such type of the collisions, such type of the problems. Those are CSMA CD and CSMA CA. Let me tell you a few points about this. CSMA CD. CSMA CD full form is collision. CSMA stands we covered already na. Carrier, sense, multiple access, media access. So CD stands for collision detection. This CD stands for collision detection. By this name, you can understand that this method is used to detect the collisions, if any, and it is used to recover the data if collision occurred. So that is the meaning of CSMA CD, carrier sense, media access, collision detection, right? Then next method is CSMA CA, collision avoidance. CA means CSMA we covered already na. CA means collision avoidance. So by this word also you can understand what is the meaning of this CSMA CA. So this is the method that is used to avoid the collision. But in the CSMA CD, if collision occurs, if the collision detected, that is used to recover the data after collision. But here, CSMA CA is used to avoid the collision. So this is the better one because we are trying to preventing the collision. Okay. Then it is used to avoid the collision by checking whether the transmission media is busy or not. Nothing but if you are using the CSMA CA, before sending the data, it sends whether any data is available in the backbone cable or not. For example, this node wants to send the data. Before sending the data, that CSMA CA is used to sense this backbone cable. If there is any data, it stops the sending the data. If there is no data is available in the main cable, backbone cable, it starts sending the data. So this is very useful to avoid the collision. Next important point is it doesn't work on recovery after the collision because here the main intention is to avoid the collision. But if any case, if the collision occurs, we cannot recover the data after the collision if we are using CSMA CA method. So this is the drawback of CSMA CA. But we can recover the data with help of CSMA CD. Next, advantages of this topology, that is bus topology. If n devices are connected to each other in a bus topology, then the number of the cables required to connect them is 1, which is known as backbone cable, and n drop lines. Very simple. So if you want to connect 10 nodes to the bus topology, just you no need to improve the cable length, main cable length. For example, you have one backbone cable and two nodes are attached to that your backbone cable. After some time, I want to attach four more systems to that backbone cable. Is it necessary to increase the length of the backbone cable? Obviously, no. Just for the same backbone cable, you can attach n number of the nodes with help of the drop line cable. That's it. So there is the advantage here. So with help of that, the cost of the cable is reduced. The cost of the cable is very less as compared to the other topologies, but it is used to build small networks. Then what are the problems or what is the problem with topology? Observe this image once. For example, as per this image, 5 systems are connected to this backbone. Let us say if there is a problem occur in this backbone. If there is a problem occurs in this backbone, the entire network will be disturbed. So this is the drawback of bus topology. Next one is ring topology. So this is the image related to the ring topology. If you observe, these are devices or nodes connected in the ring topology. Here, the network is connected in the form of ring. That's why it is called ring topology. Two ends are connected to the device. Okay. And one device is connected with two devices. Okay. One is to the previous system to the next system. Okay. Let me tell you some more points about the ring topology. Ring topology is like a bus topology. This is also one of the topologies. But two ends are connected like a ring. See here, the two ends of each and every device is connected. One end and the second end. The node that receives the data from previous computer will be transmitted to the next node. See, for example, if this station 1 or device 1 sending the data to the station 2, let us say, but where station 2 is also sending the data from this station 4. Nothing but the station 2 is received the data from the station 1 and sending the data to the station 4. That is next station. So this is the statement of this point. Next important point is, as we covered in the bus topology, the direction of the flow is two directional, bidirectional. Observe here. The data can flow from left to right, right to left, bidirectional. But coming to the ring topology, the direction of the data flow is omnidirection, unidirection. The data in the ring topology flow in a clockwise direction. Generally, it is used to transfer the data in the clockwise direction. Like this. Okay. The most common access method of the ring topology is token passing. So this is also important point. What is the access method in bus topology? That is CSMA. Then what is the access method used in ring topologies? Token passing. Let us discuss some more points. So in the ring topology, it forms a ring connecting devices with its exactly two neighboring devices as we covered. A number of repeaters are used for the ring topology with a large number of the nodes. For example, I have a ring topology where I have 100 nodes in the ring topology. Okay, I have ring topology and 100 nodes are connected to the ring topology. And the systems connected are, let us say, node 1, node 2, node 3, and so on, node 100. So node 1 is the first station, node 100 is the last station. Now, what I want to do is, I want to transfer the data from node 1 to node 100. Now, you can imagine it takes a lot of time, right? Because it need to transmit through node 2, node 3, node 4, and so on, node 98, 99. Then it reaches to the 100. Okay. So there is a chance to decrease the capacity of the signals. That's why we use repeaters here. And the transmission is unidirectional as I covered, but it can be made bidirectional also. By default, in the token ring, the flow of the direction is unidirectional only. But if you want to make it as bidirectional also, we can do that. Okay. For that, we use dual ring topology. Dual ring topology having two connections between each network like that. For example, so this is ring topology na token passing. If it is a dual ring, the flow like this. Okay. So every device has two direction data flows. Then what is token passing? The access method in token ring is token passing. So one station is known as a monitor station in the token passing method, which takes all the responsibilities to perform the operations. To transmit the data, the station has to hold the token. Okay. If X station wants to transmit the data, for that, the X station must have token. After that, only the transmission can be done with help of that particular node. Whenever the transmission is completed, the token will be released by that particular node. So when a node station is transmitting the data, then the token will be circulate in the ring itself. There are two types of token release techniques. Early token release releases the token just after transmitting the data. Very simple. So in the token passing, which station has token, that station only can send the data, point one. Then when the token will be released, we have two types release for the release. Early token release, whenever a station sends the data, transmitting the data, immediately that station can release the token. That is called early token release. Second one is delay token release. Suppose one station send the data. The station has token and the station send the data. But whenever that station received the confirmation that that particular data is delivered at the destination, then only that station will release that token. This process is called delayed token release. Delay token release. Very simple. Then coming to the advantages of the topology, the possibility of the collision is minimum in this type of the topology. Obviously, because we are using token passing mechanism. Only one system can send the data at a time. and which system has the token, that system only can send the data. And this is very less cost to install and expand the network also. Because, for example, if you want to connect one more device here, what you need to do? Just take a new system and disconnect this. Connect to the system and disconnect this. Connect with this. That's it. This is very simple to add an extra node. Expand the network. Then what are the problems we have within this topology? Troubleshooting is difficult in this topology because if you are sending any data from one station to other station, if the data is not delivered, we may not know the error is occurred at which station because all are connected in the ring manner. The addition of stations in between or removal of stations can disturb the whole topology, obviously. See the image. Suppose I want to add one more node, one more system or station that disturbs this entire ring topology. Next topology category is star topology. By the name, you can understand the way how the cables are arranged. In simple terms, you can say that the cables are arranged in the star manner, in the star shape. That's why this network is called, this topology is called star topology. Yeah, see, a star topology, all the devices are connected in a single hub through a cable. So in this network, we are maintaining a hub. For that hub, all the devices are connected in a shape like star. This is called a star topology. This hub is a central node and all other nodes are connected to the central node. See this? This is the central node, nothing but node is nothing but any device connected in the network. So hub is also connected in the network. So that's why that is also we can call it as node. For this hub, all the stations are connected. Then what are the advantages of this topology? If n devices are connected to each other in a star topology, then the number of the cables required to connect them is n. So it is easy to set up. But if you want to add one more system in the star topology, just a small cable is enough, right? Each device requires only one port, that is to connect to the hub. Now see. So if you want to connect your device with this hub, you need to maintain only one port. Then problems with this topology, if the central node, that is hub, fails, obviously the complete topology fails. See, suppose there is a problem occurred to this hub. All the systems are connected through the hub only. If there is a problem occurs in the hub, that disturbs all the network. Very simple. The cost of installation is high. Then performance is based on the hub only. For example, if the performance hub is very low, obviously that network has very less performance because probably all the processes can be done in the hub only. If the hub has the lower capacity, low performance, that obviously the network capacity will be decreased. Then advantages. Covered, no? Mesh topology. Next category is mesh topology. In mesh topology, each device is connected to the every other device with a separated link. That link is called point-to-point link or point-to-point connection or point-to-point configuration. Just now we covered different types of the configurations or connection, point-to-point, multi-point. So here, for each and every device, a point-to-point link is maintained. In simple terms, each and every device has a dedicated link from that device to all other devices. So that type of the topology is called mesh topology. When we say dedicated means the link only carries the data for two connected devices only. For example, see here, I want to transfer the data with the help of this cable. So only this link is used by to transfer this particular data only. Let us say we have n devices in the network, then each device must be connected to the n-1 devices of the network. Obviously, for example, we have 1, 2, 3, 4, 5, 6, 6 computer systems in this diagram. So for this network where we have 6 devices in the mesh topology, every system has to maintain the connection with all other 6 minus 1, 5 systems, right? Every system has to maintain the connection with all other systems. That is what? N minus 1 devices. The number of the links in a mesh topology of n device would be n into n minus 1 by 2. For example, n is the number of the devices connected to the network. How many dedicated lines should be maintained in the mesh topology? The links maintained by this network is, we have 7 devices now. 1 minute. 3, 3, 6 on. So 6 into 6 minus 1 by 2, n into n minus 1 by 2. That many links we need to maintain here. The formula is n into n minus 1 by 2. So advantages of this topology, it is robust. Obviously, we are maintaining a separate dedicated link for each and every device. So it is robust. The fault is diagnosed easily. Data is reliable because data is transferred among the devices through a dedicated channel or links. So the identification of the fault is also very easy because every device maintains a separate line with all other devices. So you can check only that particular link, particular line. Then you can easily identify the error. It provides security and privacy, obviously, because we are not maintaining any central devices. We are maintaining, try to communicate from device to device. That's why no data is stored in central device. Problems with topology, installation and configuration are difficult because we need to maintain very lengthy cables. As we have seen, we need to maintain a very lengthy cables. The cost of cables is high, obviously, because we need to use very lengthy cable. The cost of the cable is also very high. So it is suitable for less number of the devices. So that's it about this. And next we have tree topology. We'll cover this tree topology in the connection. So let me cover this one also. Tree topology. So you can observe that the topology is having the shape like a tree. That's why it is called tree topology. And it is one of the variation of the star topology. And the main important point when compared to tree topology with star topology is here we are maintaining different type of the hubs. In the star, we are maintaining only single hub called central hub. But here within the below the central hub, we are maintaining another hub called secondary hubs. And for those secondary hubs, again nodes are created, nodes are connected. So this is the hierarchy what we implemented in the tree topology. So in this data flow from top to bottom, that is from the central hub to secondary, and then the devices are from bottom to top, that is devices to the secondary hub to the primary central hub. Two directions are possible. Advantages of this topology: it allows more devices to be attached to a single central hub, so that that's why it is used to increase the distance that is traveled by the signal to come to the devices. Problems is if the central hub gets failed, the entire system will fails. And the cost is also very high because we are using more number of the cables here. See, for example, if any problem is occurred to the central hub, so obviously it disturbs complete network. So this is also one of the problem with tree topology. Next, hybrid topology. So by the name, you can understand that the purpose of the hybrid topology, hybrid, nothing but how we are using the hybrid seeds in our real time. This is also hybrid, nothing but you can create a network with help of the existing networks. That is called hybrid. So this is the combination of various types of the networks. If you observe, this is the LAN and this is the ring topology. This is bus topology. Okay. So where hybrid topology is a combination of different type of the networks. When two or more different technologies are combined together, it is termed as hybrid topology. And if similar topologies are connected with each other, that will not be called as a hybrid topology. For example, if there exists a ring topology in one branch of ICICI Bank and bus topology in another bank of branch ICICI, then you can connect to these two with the help of this hybrid technology. And advantages, disadvantages, we can choose the topology based on the requirement. Okay. For example, scalability is our concern, then we can go for the star topology. Nothing but depending on your requirement, you can choose a suitable topology. Disadvantages of hybrid topology, fault detection is very difficult because we have n number of the cables, n number of the devices. Installation is also very difficult. Design is complex, so maintenance is high, thus expensive. So designing is also very complex and maintaining is also very expensive. This is about hybrid topology and all these about topologies and types of the topologies. So this is about today's session. We'll cover the remaining topics in the next session. Okay, right. Thank you.